Hello everyone, welcome back. Today we're going to be simplifying these radical expressions with the variables. All right, so let's start with the first one. First thing I'm going to do here is I'm going to separate the root 16 from the root of x squared. So this is the same as root 16 times root x squared. And then the square root of 16 is 4, and the square root of x squared is just x. So overall, this is the same as 4x. Okay, for the second one, same kind of thing. I'm first going to separate the root 18 from root x cubed. Now in this case, neither root 18 nor root of x cubed can be simplified this kind of the same way that they could in the first one, because neither 18 nor x cubed are perfect squares. However, both of them have factors that are perfect squares, or I should say a factor other than one that is a perfect square. So for 18, let's write down the perfect squares list. So 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. And you'll notice that 18 has a factor 9, right? And so root 18 can be rewritten as root 9 times root 2, since 9 times 2 is 18. Now what about x cubed? Well, x cubed, recall that x cubed is just the same thing as x squared times x. So we can rewrite this as the square root of x squared times x. And now these two can be simplified even further. So then we have 3 root 2 times x root x. And then we can just put the radicals together and the non-radicals together, which gives us 3x times the square root of 2x, like that. And that's as best as we can do. All right, let's try number 3. Actually, I'm just going to move these down a little bit because we might need a bit more room than I had anticipated. There we go. Okay, so for this next one, it's now the cube root rather than the square root. In fact, this is the only one that is the cube root from this set. So first thing I'm going to do is separate all of these. So we're going to have the cube root of 16 times the cube root of x cubed times the cube root of y to the power of 5. And in this case, none of these are actually perfect cubes other than x cubed itself is a perfect cube. However, they might have factors that are perfect cubes. So starting with 16, we know that 2 cubed is equal to 8, and 8 is a factor of 16. So we can rewrite this as the cube root of 8 times the cube root of 2. And then the cube root of x cubed we can rewrite as x. And then the cube root of y to the power 5. Well, y to the power 5 is not itself a perfect cube, but we know that y to the power 5 is the same thing as y squared times y cubed. So we can rewrite it this way. And then we can simplify further. The cube root of 8 is 2, so we're going to get 2 times cube root 2, and then times x can just stay the same, and then cube root of y squared can stay the same, but the cube root of y cubed is just y. And then for my last step, I'm just going to neaten this up a bit and put everything that's not under the radical together. So 2xy can go together at the front. And then I'm going to put everything that is under the radical sign under one singular radical sign. So cube root of 2y squared, like that. And that's the best we can do with that. All right, let's try the next one. 45 x to the power of 7. So for this one, first thing I'm going to do is separate them into root 45 and into root x to the power of 7. And now I'm going to see if I might have any perfect squares that are factors of 45. So 2 squared is equal to 4, which is not a factor of 45. 3 squared is equal to 9, and that is a factor of 45 because 9 times 5 is 45. So then I'm going to write this as root 9 times root 5. And then for x to the power of 7, recall that this is the same as x to the power of 6, which is a perfect square, and x. And then I'll simplify. So the square root of 9 is 3. So here we have 3 root 5. And then the square root of x to the power of 6 is x cubed. So then we have 3x cubed times the square root of 5x, like that. Okay, and now let's do one last one. Here we have the square root of 125 times x to the power 5 times y squared. So first things first, I'm going to rewrite this as the square root of 125 times the square root of x to the power 5 times the square root of y squared. So does 125 have any factors that are perfect squares? Well, yes, right? 25 times 5 is 125, and 25 is a perfect square. So we can rewrite this as root 25 times root 5. X to the power 5 is the same as x is the square root of x to the power 4 times square root of x. And then the square root of y squared is y. Then we have 5 root 5 over here, right? Because root 25 is 5, and root 5 is just root 5. The square root of x to the power 4 would give us x squared. And then root x can stay as is, and y can stay as is. And then I'm going to neaten things up a little bit, and I'm just going to put everything that isn't under a radical all at the front. So 5, the x squared, and the y. And then everything that isn't a radical sign can go together under the same radical sign, and that's 5 and x. So there we go. All right, well, that's it for this one. I hope you learned something new from this, and feel free to ask if you have any questions in the comment section.